Okay, we're on the week 21 test. Remember, you can use this test to both check what you did on the test, so check how you did on the week 21 test and correct any answers that you didn't get right. You can also use this as a review. For example, this first problem we're looking at, 21.1a, the A tells you it's the first time on. It will be on a total of 3 times, so you can go back to it when you study for the week 22 test and the week 23 test. Okay, let's jump in. So the first problem is a volume problem, and what they've done is instead of just giving you the 3 sides and saying find the volume, they've given you the volume itself right here, the 315 meters cubed, and they've given you 2 of the sides. They gave you the 5, they gave you the 9, they want you to find the missing side. Remember again, and I wrote it over here, but let me write it while I'm saying it. Remember again, the formula for finding the volume of any prism is going to be the length times the width times the height. And you can do that in any order. You could do width times height times length. Order doesn't matter when you're multiplying. If we substitute the numbers in for this one, we have 9 as the length, the unknown is the width, and the 5 is the height. And there are 2 ways to solve it. One way, take that original volume, the 315, and start dividing by the different parts. So 315, I'm not going to divide by the question mark, that's what we're trying to get to. Divide by the 9, so right here, 315, solving it this way right now. 315, divide by the 9, that gives you 35. Take the 35, divide by the 5, the other number you're given, and that gives you 7, which is your answer. A second way to solve it, that I did right here, is find one side. Since you're given 2 numbers, you can find one of the faces. So get this face, the 45, and then take the total, divide it by the 45. That will also give you the missing side. Doesn't matter which of those methods you use. In either case, you're working backwards for finding the volume. All right, on to number 2. Number 2 is a little more challenging. So number 2, they give us 2 figures. They give us a triangular prism on the left. They give us a rectangular prism on the right. And they ask us to go ahead and first, we have to find the volume of each, excuse me, the surface area of each. It's not a volume problem, surface area of each. And then secondly, we have to compare them. Here is all the work. On this triangular prism, you can see there will always be 5 faces to a triangular prism. Those 5 faces are a triangle at each end, this face right here, the bottom, which is right there, and the back, which is right there. Now, depending on how you focus, you might be able to make those come out. So, for example, if you focus your eyes right here, you might be able to make this come actually as a front, not a back. But in any case, you're looking at 3 rectangles and 2 triangles. And here's our work. Triangle, 12 times 16, 12 times 16 right here, base times height, divided by 2, 192. Divided by 2 gives us 96, and since there are 2 of those, we multiply that by 2, and we get 192. Now, several people have said, but if you're going to divide by 2 and then multiply by 2, why do you do that? You don't have to, if you can keep that in your head. I like to show all my steps, so I like to find one of the triangles. This triangle right here is 96, and then know that the one at the other end is also 96. If you can just do it and then say, oh, there's 2 of those, so I'm not going to divide by 2 and then multiply by 2, that's okay. All right, let's get rid of that. And then we're going to do one of the rectangles. So we're going to do this 18 by 12 rectangle. 18 by 12, that's this right here, that's the bottom. Then we're going to do the 18 by 20 rectangle. That's this side right here, 18 by 20. Then, I got to get rid of some lines here. Pretty soon it's going to be hard to see anything. You always go back, you can rewind and see those lines that I've just erased. Then finally, we have this 18 by 16 rectangle, and that's right here. Whoops, kind of missed my mark there. That's this rectangle. So you're going to have those 3 rectangles, and you can count the faces. 2 triangles, 1, 2, 3 rectangles. There's our 5 faces. Multiply everything out. Now, when we go over to the rectangular prism, it's actually a little bit easier to do a rectangular prism. They're going to be 6 faces, and they're going to be pairs of rectangles. So here's the first face that I did, 15 by 5, and that's also going to match up with that face. So there are 2 of those. The next face would be 25 by 5. Well, there's the 25. Here's the 5. And there are 2 of those. So there's a top and there's a bottom. The 15 by 5 was an end and an end. And then if I get rid of both of those, so I can see where the third one is, so let's just go around here. Let me erase all of that. Again, you can rewind if you want to see what I've erased. Then the last face, the 25 by 15, notice you have a 15 here, which means, let me write it in a darker color. If that's a 15, then this is also a 15. So our 25 by 15 is right here, a side, and it's this other side right there. 6 faces. Multiply everything out, add it together, we get 1,150. Our triangular prism was 1,056. I think this is probably off the edge of the screen now that we're recording this, so let me write it in. And the 1,056 meters squared was less than the 1,150 meters squared. All right, on to the back of the page. So here we go. They give us a circle. They tell us the area of that circle is 81 pi centimeters. Area, so here's the area formula right here, pi radius squared. And they want to know what the circumference is. And if they want to know what the circumference is, our question is, okay, what's the radius? Because you need a radius to find a circumference. You need a radius to find an area. So radius is the big thing in circles. So we divide by pi first, take our 81 pi equals pi r squared, do our dotted line. There's my dotted line. And we divide by pi first, gets us 81 equals r squared. We need to do the square root of 81. Now, normally you'd need a calculator with a square root key. In this case, you can probably figure out what times what makes 81. So 81, the square root, is equal to r. R is equal to 9. We bring that up, plug it into the circumference formula. 2 times pi times r. So we have 2 times 3.14 times 9. Do the 2 times 9 is 18 times 3.14, and we get 5652. This note right here, you can't see all of it because it kind of goes off the screen. That's the square root, so the 81 r squared. All right, so 56.52. That is the answer to the first question. Then that comes down, because the next question is, if that circumference was increased by 15%, there's the 15%, what would be the radius of the new circle? So we increase it by 15%, which is 8.478. We bring that down in its rounded form. We've been rounding everything to the nearest hundredth. We bring down the 56.52. We add those together. There's our new circumference, 65. We bring that up and match it with the formula for circumference, pi times radius squared. Divide by pi again. Now here I show it as the symbol pi. Here I show it as the 3.14, which if you come up to the top of the problem, they said use 3.14 for pi. I get 2r because the pi disappeared, so 2r equals 20.7. Divide everything by 2, and I get 10.35 as the new radius, and that's my answer right there. So there you go. There is the week 21 test. Here's my work, by the way. I'm not going to go through all this work, but here's my work for the extra credit problem. I figured out each of the pools. The big thing to read here was will not meet. So A, B, and C all were between 12 and 15. D was not. D was only 11.83. So that's the week 21 test. You can go ahead, use it to correct your own work, use it as a study guide, and use it to help yourself prepare for getting these problems correct in the future.